Okay, I'm now recording. Michael, he gave a presentation, was it last year? On
Yeah.
almost everything's last year at this point.
Yeah.
Um,
It
on
was right at the beginning of the year.
yeah.
Also, you're going to need to enable sharing.
Oh yeah.
Otherwise, I won't be able to share. It
Yeah.
was
So
right at the beginning of the year last year. Basically, it's basically the same presentation, but I've done a few extra things to it. And what I'm going to do is try to leave a little bit more time for uh, questions in here. So I'm not going to read the slides verbatim, but what I'm going to do is go through them, give you a Cliff's Notes version of what's on the slide. And if you have questions, I'm going to try to leave it up so that you can read it in the background. But if you have questions, feel free to at any point just interrupt and ask, and I will answer your question as best I can. My email address is in at the end, so I'll put it on screen and leave it there for a minute. So if you have questions and you want to send me email to ask those questions, feel free. I will be happy to answer them. So let me go ahead and try to share my screen again. Good. And that one, share. And let me know when you can see it, and then I'll get started.
I can see it.
Excellent.
Yeah.
All right, then let's go into the presentation mode here. Where is it? There it is. Nope, that's not it. Oh well. There it is right there. Okay, as you can see here, the purpose of this is to show you how we can use 3D printing in the model train hobby. Basically, it's a meld of two different hobbies, and by melding the two of them, getting the best out of both worlds, you can get something that's more satisfying in the other. One of my big hobbies is 3D printing. Model train, I used to be really into that when I was a kid, but my son is more into that right now. So I wanted to do something to help him out. And I figured I could actually 3D print some of the pieces, some houses or whatever that he could put in his layout. And so that is what I tried to do, and it has worked out really well. Um, I've helped him with his layouts. I'm a little bit crafty, so I do some stuff, but this is primarily uh, my way of helping him in his hobby at this point. I've kind of moved on, but I have like a toe dipped in the water of model trains. My agenda for this meeting is, of course, just these few bullet points here, the basics, what you can print, what's required to get started in case you want to get started. And if you happen to be interested and want and have some questions, by all means, this is a good place to start, and the basics of what the costs are. That image you see on the screen there, that is an image of the first 3D printer that I purchased. I purchased it used. Actually, that's a stock footage image of it. The one I purchased looked exactly like that. I've made a few modifications to it, but it looked just like that. It worked great until it jammed up, and then I was in the process of getting a new one at that point anyway. That 3D printer there was under $200, and it was a great starter 3D printer. I have no real complaints about it, and in fact, it's across the room right now, waiting for me to do a repair to it.
Sorry, Michael. Do you see that emit button?
Admit button.
Yeah, at the top. My mouse isn't working doing the full screen for some reason.
I don't see an admit button.
Okay.
Too small.
Can you unshare your screen for just a minute?
Yep. All right, I stopped sharing.
Okay, hang on. Let's see. My mouse is really.
Participants.
There we go. Okay.
All right.
Go ahead.
I will share again. Screen one, share. And once you guys verify you can see this, I'll move on to the next slide. Okay.
Got it.
All right. So this is the basics of 3D printing. As you can see here, this is a Prusa i3 Mark III printer. This is my new printer. It has a much bigger print volume. As you can see, that great big orange box is the entire print volume. So I could print something literally as big as that on my new printer. But this question here is, how do FDM printers work? You can see the full what FDM means right here, but basically what it does is that it melts the plastic, runs it through this extruder, and lays it down layer by layer. So it takes a 3D object and basically cuts it into slices. I'm hoping that you can see my mouse as well.
Yeah.
Basically, it cuts it into slices along this horizontal axis here, along this horizontal plane, and then it prints. It lays down plastic on each layer, one at a time, and these layers can be as big as well, depending on the nozzle, it can be as big as a millimeter thick, or as small as 5/100ths of a millimeter. So if you have something that has a lot of detail, you want the layer heights to be small so you can see that detail and it'll be nice and smooth. If you have something like a block like this, you want high layer heights so that it prints it quickly. And the big drawback to this one is that it takes, the more you have, more of your bed you have filled up, the more complex your print is, the longer it takes to print. However, as soon as it's done, it's ready to use. It just pops off the bed and you can immediately use it. Go to the next slide. And this one is a resin printer. This is called an SLA printer. This one uses basically the same sort of technology, except the same basic idea, except there's a pool of resin in here. And it's a photoreactive resin. It reacts to sunlight or any light at a certain wavelength. And once you shine that kind of light on it, it will harden up. And as you can see here, it's also kind of upside down. In this case, the bed's on the top and the print is printed upside down. So it adheres to the bed, and this bed comes down into the vat. At the very bottom of the vat, there's a clear plastic film, and the light shines up from beneath it, and it illuminates the entire layer. And then the light turns off, the bed moves up a little bit and back down into the liquid to get a new liquid underneath it, and then the light comes on to shine the next layer. And it does this repeatedly, eventually pulling the entire thing up out. And this allows for incredible amounts of detail. And the advantage to this is the amount of detail you can put into your print. But the disadvantage is that there's some more post-processing that has to happen with this. But it kind of depends. If you're doing HO scale or larger, the FDM printer should have plenty of detail. Getting some feedback off of somebody. I think it might be you, Jim. Anyway, if you are doing something smaller, like an N scale, or even smaller than that, you'll probably want to use like an SLA printer, because then you'll need that detail on all your prints. Any questions so far? Okay, let's move on. And this is actually the printer that I have. I have a resin printer as well as an FDM printer, and this is the resin printer that I have. What things can be printed that apply to model railroading? Well, all the pictures you see here were printed using a 3D printer. In this case, it was actually then painted. This is not actually mine. I did not actually do this painting, but somebody else did. But I have the model so that I can print out for this piece of scenery. This bridge here, everything that's in blue, that was printed out with a 3D printer. This entire water tower, this was printed out with a 3D printer in different colors of plastic. And I think they probably did a little bit of black paint to get the ribs of the thing. But the ladder, the tank, the roof, all of it was 3D printed. In fact, last year when I did this presentation, I had some of this stuff that I had already 3D printed, and I had it in the room with me. I gave it all away because I didn't have a layout that could use it. But these are some of the things that you can print with a 3D printer. There's a lot more out there. In fact, there is a site that I use to get free 3D printer model stuff. There's also sites where you can go and pay for it. If you can find a site that has 3D printer models of what it is you're looking for, you have the option to acquire it, and you can scale it up or down depending on what size model you're using, or what size train modeling you're using it, whether it's N scale, Z scale, HO, etc. Here are a few more items that I printed that can be printed: a covered bridge, a house. I don't think this car was 3D printed, but that should give you an idea for scale. And even things that people won't see, like cable management. You can 3D print this white piece here and manage your cables underneath your model. Um, it's great for that. Because you can 3D print these in probably about 20 minutes. You can 3D print a handful of these in about 20 minutes because it doesn't have to be very high quality. You can put it in draft mode and it'll print it quickly, and you can put it underneath, and it costs maybe a penny or two per piece, as opposed to going somewhere and buying all these parts and spending an arm and a leg. All of these prints, once you print them out, you realize that you got something that's great detail, it's ready to be painted, and you didn't spend very much for it. I'm guesstimating this piece right here, this yellow piece, probably costs on the order of about 25, 30 cents maybe. That's including the materials, the time, the electricity, everything. Probably about 25 to 30 cents. Here's another 3D printer. They come in all shapes and sizes. This one has a decent sized print bed, but I don't have this one, but this is just a picture of one. And where can you get access to a 3D printer? Well, you can get these pretty much anywhere. I'm pretty sure that if you were looking for it, you could find one in a Walmart, or at least Walmart's online store. But any place that sells electronics, Amazon's a great place. There's a lot of places out there you can buy a 3D printer. So you don't have to have the one that I have to do this stuff. You can get started for under 200 bucks. So if you have your own or you have a friend, as long as they have some downtime on their printer, maybe they can print something for you. Where do you get the object models? The models, here's one that I found on Thingiverse. It's of an old abandoned house, so you can see it's starting to fall apart. It's a little dilapidated. But once you print it, prime it up and paint it, looks great. I find mine pretty much on Thingiverse, and another place is Shapeways, but these are only a couple of the multitude of places out there that you can find 3D models. You may find people online who've used CAD to model a real life object, a real life train car or an engine or whatever. And as if they are offering them online or even for a small fee, once you have it, you can print it out as many times as you want. Or you can, if you have a friend who's really good at CAD, maybe you can give them the drawings and they can turn it into a model. I'm not particularly good at CAD. I can make really basic things, like maybe the cable management. I could probably come up with something that would do that. But as for making a house, that's a little bit beyond me. So if you become interested, how do you get involved? How do you get started? There are several people. There's at least 2 people on this call right now I know of that have 3D printers. Ask your members, ask your friends, ask anybody. I'm fairly certain that in pretty short order, you'll be able to find somebody with a 3D printer. If they have a little bit of time, maybe they'll be interested in getting you interested in the hobby as well. Doesn't for just a 3D printer, FDM 3D printer, it doesn't really cost a lot to get started, and it doesn't cost a lot for the materials. It's fairly easy to get going and not spend a whole bunch of money. Let's see here. And so in general, what are the costs? Typical FDM 3D printer with a decent sized print area, anywhere from $200 to $1,000. The one I have, the first one I had was underneath $200, and the one I have now is around around 750 when I bought it. And for, I'm sorry, what was that?
As a kit.
Yeah, it was a kit, and I had to put it together. But in putting it together, I learned a lot about how it works. So that there's pros and cons there. You could have gotten it put together, and it would have cost more. It would have just come in a bigger box, and it would have been completely assembled. It would have cost more. A roll of filament. I'm sorry, let me finish this. About $350 to $1,500 for an SLA printer. That's if you buy the printer and its associated accessories. I mentioned earlier that there's some post-processing, and I'll get into that a little bit later. That post-processing for resin printers is what drives the cost up a little bit. A typical roll of filament, which is the plastic that gets melted, costs between $15 and $35, depending on what brand and quality that you're looking for. And the same thing for resin. It's about $25 to $40, depending on what quality you're looking for, what kind of resin you're talking about. And like I said, a 3D printed part can range from a few cents to a few dollars, depending on size and complexity. And the time it takes to print can be anywhere from a few minutes to a few hours. All right, and here's a couple of pictures of my personal 3D printer. As you can see here on the left, this is the front, this is the control, and the print bed. I've clearly not cleaned my print bed in a little bit. There's a little bit of stuff in the middle, but it's got a decent sized area. This is approximately 8.5 inches by the same depth, 8 inches depth, and it goes up about 9 inches. So I can get a decent sized cube in that space. Here's another view of it. And here's a view more to the side. And you can see I actually have a webcam set up to view it so that I can monitor it when I'm not here, when I'm not directly in front of it. Here's my resin printer on the far right here. You can see it. It's set up. I got. You can notice the gloves in the background. You don't want to touch the resin. That's one of the drawbacks to the resin printer. It requires a little bit more care, and it requires a little bit more to be a little more safety conscious, safety minded. So once it comes out of this, I then put it in this. This is basically a jewelry cleaner. It's a sonic jewelry cleaner. I put the part in there. There's some, I usually use IPA, which is alcohol, isopropyl alcohol. And I put it in there and to vibrate and clean the excess resin off of it. Once it comes off of there, I give it a water bath. And then I put it under some light, some UV light to cure the part, to complete the curing process of the parts. So it takes a little bit more work to get them to deal with a resin printer, but the amount of detail you can get from a resin printer is incredible. There's a lot of content out there on YouTube about resin printers, comparing them, how to get the best prints, etc. And you are welcome to find that. There's so much out there that it's almost not worth me trying to put a link in my presentation. There's also the same sorts of information out there for FDM printers. There's a lot of them out there, and you can get a lot for very little with these kind of printers out there. So this is the end of my presentation here, but I do have a couple other things I want to show you. I'm going to leave this part on the screen. However, I'm going to switch over to my Prusa Slicer software. This is my Prusa Slicer software. This is for my FDM printer. As you can see, you can move the bed around and take a look at it. But what I'm going to do is really quickly open up an in-scale fence print. And zoom in on it. And as you can see, this is just a little fence, a pasture fence, and it's already an in-scale. If I were to slice this, okay, slicing's done. Export time. Let's see here. It thinks estimated printing time for this one single piece is about 2 minutes. So I could start this print right now, and in 2 minutes, it would be pretty much done once the bed and the nozzle heated up. I already have this extracted and pretty much ready to go. So I'm going to switch over to a different view here. Let's escape out of that. And actually, I'm going to send it to the printer while we're talking about it. Which one is this? This one. I'm going to send this off to my 3D printer. And start it printing. Let's see, let's go to the temperature. And you should see. Oh, that's right. I have to click on something over here. Okay. I need to update the firmware on my printer, so it was waiting for me to acknowledge that it's okay to print without me updating. But as you can see, it's already started to heat up the nozzle and as well as the print bed. And pretty soon here, it will start to level the bed and it will start the print. This print will likely not be done before the end of the meeting, but I just wanted to show you that it can be done pretty quickly. In fact, the one I have, I believe, is going to print 5 of those fence sections, and it should be done in about 6 minutes. Let's see here. This is the actual fence. This is what it's going to look like, and this is where I got it from Thingiverse. I pulled this very model, sliced it in Prusa Slicer, and threw it to my printer through Octoprint. All of these things you could just have the printer directly attached to your computer. I am a techie, and so I wanted to be able to monitor it. I wanted it to be able to be controlled from across the room or across the house. So I didn't have to have it directly attached to my computer. So I spent the extra $40 or so and about 20 minutes to figure out how to get this set up. But this is, as you can see, the red light up there. It's in the process of heating up. The bed's at 52 degrees C and the tool is already at temperature. So any moment here, it'll actually start its process. I also have the Cheeto Box software where I could do it on my resin printer. As you can see here, there's only 3 models on here. And that's because the print bed is much smaller, and it has all these supports. These supports are what's on the bed, and if I turn it over, this is actually the orientation that it will print from. It'll print upside down because the bed has to come up out of the resin. Oh, it looks like it's going. I just heard it in the background, so let me switch over here, and you'll see the print head come down into view as it starts its process of checking the bed level. It's going to check my bed in 9 different places, figure out whether or not it's warped, and then make adjustments to compensate for that. Then it's going to clear the nozzle here at the beginning and then start its print. And it's going to put a perimeter around the outside of it, and then it'll start the first layer of the print. And it's not going to take very long at all. This is the smaller one. Yeah, this is the smaller one. It's going to take about 2 minutes starting now to print this piece. And as you can see, it's laying down black plastic layer by layer. Does anybody have any questions so far? I noticed everybody was really quiet.
This is Brent.
Go ahead.
So I'm interested in making a whole bunch of identical windows in O scale.
Oh, yeah.
Is that something that could be done?
Oh, yeah. Let's see. When I showed you, I'm going to go back to it. When I showed you this, there's a single piece here. However, let me switch back to piece mode. I can change this out and tell it to set it to a total of 5 copies of the same thing on here, and then auto arrange it. And now I have 5 copies of the same piece to be printed. So if you had a window and I had put it on here, I could fill the bed with copies of that same window.
Okay, can it make all the dividers, the mullions and everything?
Yep.
Okay,
Just, I mean, as you can see here, this is, this is N-Scale's fencing for a pasture. And it has several parts of the fence. It's all together, one piece. And of course, when it's done, you can cut these off to length with a simple tool or a knife, a sharp knife. But you can do whatever you want with it. And this right here, let me go back to Octoprint to see what it says. It says, yeah, it's already done. It just finished that one piece of fencing. And what was it? A cost is 1 cent. It cost me
I've
1
got
penny.
another question, Michael.
Yeah, go ahead.
So what is the strength of this? Is that something that's going to break easily or not?
It's probably comparable to say this identical part that you've purchased. So if you purchased a piece in a kit, think of like a model airplane or something like that. It's the same sort of plastic. It will give and flex a little bit, but yeah, it is breakable. I mean, it is plastic. It's thin plastic.
Okay, years ago I modeled in Lionel 3-rail, and they had a lot of parts back around World War II that were made out of something called Bakelite, and those things are fairly fragile. So like a boom on a crane or a base on a Lionel accessory, could those be 3D printed?
Yes, certainly. If you the prints are, like I said, they are flexible, and if it's thin like this one, there we go. I just got it off my print bed. If it's thin like this one, it's not likely to break. It'll let you bend it quite a bit. I'm not sure if the camera will show very well. Nope, it's not gonna. Yeah, there you go. Got to put it in front of my face, but you can see it there in front of my face. But I'm bending it quite a bit, and it's not breaking. In fact, I just bent it into a loop, and it has not broken.
Well, what if you want something? What if you want something that's fairly rigid that doesn't bend, that you want it to be able to hold a little bit of weight?
Yes, you can print that too. The plastic, this is called PLA plastic, and basically the more layers the thicker the print is, and the other part is that if you can put like the regular construction, when you put things at right angles, it becomes stronger. If you box it in like a crane, it becomes even stronger than that. So it can do quite a bit. I have 3D prints of, yeah. For instance, Mike Dean has a 3D print of a backhoe.
This is an N-scale backhoe.
Yeah. So you can get very detailed on it, and it prints really well. And you can get strong prints. And depending on which plastic you use, PLA is the least expensive, and it's the easiest to deal with. But you can use PLA or PETG. That's a different type of plastic, or ABS. If you use ABS plastic, it is indeed ABS plastic. It just takes a little bit more work. It costs a little bit more, but it's really the sky's your limit. You can make them strong. You can make them weak. If you were to make a solid thing like that backhoe, if you made it solid, it would be solid plastic. You could also make these things hollow, and they have a little bit cross webbing to make them strong. Any other questions?
Yeah, so here, I don't know if anyone can see my screen. I printed this little whistle, and that's pretty sturdy. And then these were just test prints that came with the printer. And
what kind of printer do you have, Jim?
I got the Prusa Mini, and they upgraded it to the Plus for free. So that was pretty cool. And then I also have a resin printer, but I don't have time to use either one of them. So that's about all I've printed so far.
Hey, Michael, last week, the Steel Mill Modelers Special Interest Group had a Zoom meeting, and one of the people in that group has done a lot of 3D printing, but he also has a lot of CAD knowledge. And so he has created, whole buildings that he can do on a 3D printer. But as you get bigger and bigger pieces, what he's found is to do them in pieces.
Yes.
Not do a whole house, but to do the walls, the roof, the separate pieces.
Mhm.
And anyway, and he had a couple of bag houses that he had created for a steel mill, and that were quite large structures when you got them all put together. But
Yeah.
he did these individual pieces and worked it out really nice.
Yeah, exactly. I mean, basically the sky's the limit. As long as you can fit it on your print bed, you can print it. Or if you want something that's larger than your print bed and you can have it in pieces like a wall or a wall section, and you can take those apart, take those off the print bed when they're done and glue them together to build.
Here's an example,
Yeah.
Michael. I don't know if you can see my screen, but I bought this off eBay before I got the printers, and it's basically a kit of a house, and then it comes with all the little
Mhm.
pieces. And Brent was asking about windows, and this includes windows and detail pieces like the chimney. They're printed separately, so that helps to paint it as well as having
Greater detail and structural integrity. You can you can print it in a bunch of different pieces and glue them together, and you can get something that's incredibly detailed with very small parts. You can print them, paint them all separately, and then put them together, and you don't have issues with painting. And you can create something that's huge and spend a whole lot less. Or you can just print parts of it if you're going to have like a diorama, or if you break a window, you can reprint a window.
So I have this base to a Lionel 165 remote control crane, and it's got legs on it and feet on the corners.
Mhm.
And it's several, so can you print something like that? And who would do that for me? How would you do the artwork to do that?
Well, if you had the drawings, or if you could give that to somebody who's skilled in CAD, they could take the measurements and put together a CAD drawing. And then once that exists, they could save it as an STL, and that could get sent to a printer and it would be printed. There's a bunch of printing services online where basically you give them the drawing and they will estimate how long it'll take to print and how much they'll charge you for it. And there's a bunch of them out there. If you have something like that part that you need printed, it can either be scanned, 3D scanned, or you can hand it over to somebody who's skilled in CAD and they can just take measurements and build the electronic model of it. And once they do that, once you have the electronic model of it, as long as you can find somebody with a print bed large enough, they can print it.
How big is that, Brent?
It's 6 by 6.5 inches, and it's probably a half-inch deep, thick.
Because it looked pretty simple.
Yeah.
Okay,
It may have
well,
some holes. It may have a bunch of holes and nooks and crannies and such in it. Yeah, so you'd have to match those up, but it would likely print if it has a completely flat surface. That surface would be down, so it would likely print upside down with the feet up.
well, it's got the set. Okay, it's got a depression on both sides. It's got a ridge around the edge too.
Ah, okay. We could probably figure out a way to print that. Anybody with good CAD skills would be able to figure out a way to print that. I mean, I can't take that as it is and print it because I'd have to convert it from a physical object into the electronic equivalent model.
Well, if it's something that's fairly on the, on the collector's market, Mike, somebody may have already CAD it and put it out there.
Exactly.
So, a little bit of investigating that work might have already been done.
Exactly.
That's
It may have already
made
been
out
done.
of Bakelite, and it doesn't glue.
Yeah. So if you could find it, somewhere, then it can be printed.
And that's part of the frustration I had when I I'm still just getting into it, but just because you have a printer doesn't mean you now have a window. You have to either find the window or make the window. And like you said, there's a lot of these parts out there, but being able to create your own object in computer space, learning how to do CAD, you have to know that or know someone who knows it before you can even use your own printer or find the file that you want.
Yeah, that's a little bit of a drawback to a little bit of a drawback to it. It requires you having the electronic version of whatever model it is you're looking for. A lot of them, like I said, a lot of them are out there. I use Thingiverse and Shapeways, but let's see here. Let's try for InScale. I'm just doing a quick search on Thingiverse, and let's see what it comes up with.
Hey, Mike, just quickly, there's a black bar that's on your screen. Are you seeing that? It's blocking out where you were typing.
Ah, no, I'm not seeing that bar.
I'm seeing that. I thought it might have had to do with being the host.
No, we're all seeing it.
Okay.
Oh, okay. I think I see it now. It's this. Okay. How about now? Is it better?
Nope, still there.
It moved.
It moved. Okay. It's the screen that you're sharing thing.
Okay.
Yeah, you can relocate this, but here you go. Again, all of these things exist. As you can see, this is not necessarily something that you do for your trains, but as you can see, a lot of them have lots of pieces. Lots of different pieces you can print. This, because of the size and the level of detail, I would do this on a resin printer. But there are, as you can see, there's some of these models have lots and lots of pieces to them. Let's see here. Here we go.
So, Mike, I've got a question for you.
Go ahead.
So, when you were deciding on, take for instance the, oh God, I can't think of it, the deposition printer.
Mhm.
The what drew you towards that model, and what issues? I mean, obviously you bought that one, but what things were you looking for in a printer, and what things were you looking, or were you trying to avoid of what you knew?
Well, like I said, I bought my first one was I bought it for under $200.
Okay.
And what I learned in printing with it for the better part of a year is things like what happens when your bed's a little bit warped, or if your parts don't stick very well, you get a few failures. And what I learned in using it and my research in it is there are some features that some printers have that reduce the number of failures, print failures that you have. And the more of those features I could have, the happier I would be, because nothing feels worse when it comes to 3D printing than having a giant print that's going to take days to print, and you start your print and you keep coming back and checking it, and it looks great, and it gets like 98% complete, and something happens and it's a failure. There's no worse feeling than have wasted all those hours. And it was something that if I had this feature, I could have avoided it.
What would those features, or shall I say marketing buzzwords, be that people might want to consider in looking at a given printer that they may be looking to purchase?
Printers that have crash detection. That basically means that the gantry that's moving over depositing the material, if it bumps into something that knocks it slightly out of calibration, that's called crash detection.
Okay.
The printer that I have, the big printer that I have, has that built in. The first printer I had did not have it built in, so if it would bump something and get slightly out of alignment, it would continue to print like everything was fine, and your print would go up, and then suddenly it's skewed, or skewed, and then it would continue to go up, and that's a failed print. Though there's no way to detect it. The one I have now that I use the most that you just saw, that one has crash detection on it. So if it bumps into something and detects that it's crashed, it'll actually raise the head up a little bit so it doesn't hit anything, re-zero the head to recalibrate, and then go right back to where it was and continue to print, and you'll never see any issues with it.
Okay.
Those are some of the features that I was looking for. Like I said, the bed warping, a metal print bed is hardly ever completely flat.
Right.
And if it warps just a little bit, you can get where it's a little high here, a little low there. The issues with that is that sometimes it won't stick to some places, and other places when it tries to extrude, it's so close to the bed that it can't extrude anything, so it doesn't lay down any plastic. So little things like that I learned from the first printer over time. But don't get me wrong, a small printer like that is great.
Right.
Most likely, more times than not, I had successes on my small printer, the initial printer that I had, and I was very happy with it. It's just that as I got a little more advanced, I wanted some of the extra creature comfort features, and that's what I looked for, and that's what I got.
Is
I had
the one
same
it-
experience.
Go ahead,
Is-
Dallin.
is the one that you're using now? Does it have a different, like I guess, a non-metal bed?
Oh, it actually does have a metal bed.
Okay.
However, I'm gonna take it off. It's held on magnetically, but
Okay.
as you can see from the video there, I can pull it off. It's a spring steel sheet.
Okay.
I'll try to hold it up in front of me so you can see. I can
Yeah,
bend it. It's right in front of my face here. You can see that I can bend it,
Right.
right? But it's strong spring steel, and it's
Okay.
coated on both sides, so I can flip it over. But basically, if I have a big print that has some height to it, when I'm done printing, I take this whole bed off and simply do that, and one side of it pops free, and I can just pull the whole thing off. It
Okay.
makes it much easier to get the prints off.
Okay.
If you don't have something with like this feature,
Mhm.
you have to kind of get a scraper underneath it on one corner and pop it up, and sometimes you damage your print a little bit.
Okay.
But if you can have something like this, it's much better. The other part is that when you use a scraper, you alter the bed level.
Right.
And when you do that, say you have a high spot and a low spot across the bed, and it has issues with adhesion. The one I have now, I had to get it close, and then the first thing it does on every print is that it checks the bed in multiple spots to figure out if it's level or if it's warped, and then it mathematically adjusts for that.
Okay.
So I was looking for that feature, but not all of them have it.
But that's an important feature though, because if you don't have automatic bed leveling, you have to turn knobs on the bottom with a piece
Correct.
of paper and slide it around. And
Yeah, and it's not difficult to do. It just takes time. So
Right.
this is a creature comfort that reduces that time.
Okay.
Any other questions?
Michael, I've noticed online that some people, when they show the print, they're printing at an angle,
Mhm.
and they'll have like runners going down to the base.
Yep.
Is that just a different style of printing as opposed to just flat?
It kind of depends on what it is they're trying to accomplish. If they have something, the bed that I have, that spring steel sheet, is smooth as glass. There are some with texture on them, and if you're trying to print something that has a really flat finish on it, you want to have the one I have. But if you don't have that one, if you print it at an angle with supports on it, you'll have an almost flat finish. It'll have
Okay.
slight bit of texture, but it'll be pretty much flat. And then you can put sandpaper to it and flatten it out
Okay.
completely. Then you can clean it up, spray it, paint it, and you got something that's absolutely beautiful. But if you need something with supports, say an arch, right? And if an arch, you want to support the center while it's printing, because it'll get to a certain point and you can't print melted plastic over nothing. So you have to have some supports in there. And there's a certain angle, and it depends on the printer. It's a certain angle at which it can't support the plastic anymore just by being on the previous layer. and it can't cool it off enough to get it stiff to hold on to itself. So you have to have supports under there. And sometimes you can reorient your print on the bed to minimize supports and minimize those kind of issues. And that you gain that with experience. You'll be able to look at a print and go, oh, there's no support here, and it's going to need support there. And you can either add them depending on your slicer software. So you can either add those supports, or you reorient it and have supports under everything, but you reorient it a little bit and minimize the number of supports you need.
Okay, cool.
Also, also for the resin printing, it's a different technology in the way that it does the layers.
Mhm.
It needs to be at an angle for the way it's lifting off the FEP.
Yeah.
But that's a whole nother topic, I think.
Yeah, I mean, the differences between FDM and SLA printers are incredible. The basics are the same. They take a 3D object, cut it into layers, and then print each of those layers at a time. That's the basics. How they accomplish that is vastly different. Any other questions?
So what you're saying is that if you were going to print like a double hung window, you'd have problems because you have too many different surfaces that would not come in contact with the bed.
Potentially, yeah. Yeah, depending on which orientation you printed that. On a double hung window, I've done this enough that I wouldn't print the window up vertical. I wouldn't print it sideways like that. I would print it on its side on the edge, because then you'd most likely have all the support you need. And I could also print it with supports and tell the software, don't attach the supports inside the window, attach it to the bed. That way it minimizes the number of possible burr points on your print, on your finished print, that you have to sand out.
Thanks.
Yeah, no problem. Any other questions? Awesome. What I'm going to do here is go back to that, and you can, as you can see, my email address is right there. Feel free to send me questions via email, and I'd be happy to answer them.
Hey, Mike, if you're only going to choose one type of 3D printer, which one
would it be?
would you choose?
Knowing what I know now, if I could only get one, and in terms of model trains, if I could only get one, I'd probably get the FDM. I would likely not get the resin, and the reason for it is because of all of the behind the scenes uses for it, and the fact if I'm going to paint it, if I put my FDM at its highest detail, that's usually going to be plenty for me, or plenty for my son. If you are way into it, perhaps then you'd want to have a little bit more.
I was going to say the opposite.
Yeah.
Just because the other one will be more detail.
Yes.
And I was confused when people would say SLA and FDM, and I like to think of it more in terms of resin versus filament. There's different types of resin and there's different types of filaments. But the resin one, it does have more post processing.
Yes.
You have to clean it and you have to cure it a little bit more.
Yes.
Compared to the filament one, I took this off and it's ready to do whatever I want with it.
Exactly. Yeah. You'd use the filament, the FDM printer, and as soon as it's done, you can use it. You can take it out to your paint booth, spray it or paint it or whatever you want with it immediately. With the resin, you may get more detail, but there's a lot more post processing. You have to take it off. You have to clean it off. You have to rinse it off, let it dry. Then you have to complete the curing. And you can avoid a bunch of that by when you take it off the bed, you just put it in a vat, a small container, put a lid on it with alcohol in it, give it a gentle shake for 5 minutes or so. Then with your gloves on, take it out of that, put it in another little like I don't know, plastic container, rinse it with some water, and then let it sit and dry, and then stick it out in the sun. You don't have to buy a bunch of extra things, but it just requires you to do more manual work. So, but like you said, you can get great detail, extremely good detail with a resin printer, and the parts are fairly strong. And then you can paint them and airbrush them or do whatever you want with them. It's just that what level of detail are you looking for?
And that was my debate. Which one should I go with? And I had enough in my train funds that I could buy one of each. And it just so happened that the resin one came first, and I just this last week got the filament one, and I really liked that I didn't have all that post processing, but I haven't had time to really dive into it yet. But the whole idea for me was the resin one could be for doing bigger structural things like an entire house. But what if I wanted to do a fine detail on windows and do the mullions and just do everything in more detail? Then I could do that on the resin printer.
Exactly.
So like someone else was saying, that you don't just print the entire house, although you could, but if you wanted the detail, you print the railings separately, and then you can paint them and then apply them. Basically, you're making your own kit.
Exactly.
That's what I wanted to do from behind it.
Yeah, and like you said, the things that don't need a lot of detail, but maybe are bigger, you use the FDM printer for that. And then the pieces that you have to have all that detail to see, or that you're looking for that detail, you do those pieces in the resin. And once it's cured and everything, when you go to paint it, you paint them separately and then glue them together, and you're done. Ideally, you'd want to have both. But if you can't afford both and you only want to have one, it kind of depends on the level of detail you need. If you're doing a larger scale stuff like maybe HO or larger, you may not need that level of detail, but then again, you may want it. So it completely depends on the individual user and what level of detail they are. If they're a beginner, then they may not need that detail because it's just too much. But if they're more advanced, that may be what they're looking for. It completely depends on the user.
Michael, you would agree though that you don't just take a printer out of the box and turn it on and expect it to work automatically. This is a tinkerer's hobby. To me, it's like I wouldn't tell my grandmother that she should go get a 3D printer.
Right. It does take some time, and it usually takes a little bit of tinkering. However, like with the Prusa, it's really expensive. You can get one that's pre-built, and basically you pull it out of the box, install the software, and connect it to your computer, and you're ready to go. If you can do that.
You still have to experiment with different temperatures and different speeds, and so there's a lot in this hobby that is very much you got to be interested in tinkering.
Yeah,
I think
there's a bunch of preset information that comes, for instance, with the Prusa. So if you have this Prusa model and you have this filament that you're going to use most of the time, you can go to those presets and it'll automatically adjust your printing temperature, your bed temperature, your print speed, etc., based on tried and true methods with those things, so that you can minimize that depending on the printer you get. Some of them have those creature comforts built in, while some of the lesser expensive ones don't necessarily. But a lot of this information is still out there online. So the more time you spend researching it, the better and better your prints get.
And that's partially why I went with the printers I did. Was I know you had mentioned this could be a hobby within a hobby, and I didn't want to have another hobby because I don't have that much time. But I knew that I'd be doing some learning, but I didn't want to, like the printer that Michael bought, it took what, 8 hours to assemble.
Yeah, 6 to 8. Yeah.
And I knew that would be kind of cool to learn all the ins and outs, but the new mini that they just came out with is the one I got, and it took me a half hour.
Exactly.
And that was plenty of time to understand enough and still be able to use the printer. And I didn't want to have to know every single little detail about it.
Right.
But then the same thing with the resin. It's basically I didn't have to build anything, but but there are enough presets in the software that I can play with it without having to spend hours and hours playing with it.
Exactly. Yeah, so it depends. If you want the creature comfort so that you don't have to spend hours and hours and weeks learning about it, it typically takes a little bit more money up front.
And that's what my plan was. I was willing to pay just a little bit more so that I wouldn't have to spend as much time.
Yeah. Yeah, so there are some well-known brands out there. You can research them. There are some that are really good with the creature comforts, the creature features that minimize the amount of back-end research you have to do. And there are some that are just less expensive, but you have to tinker with them and be more involved in tune with that part of the hobby. So it depends on where you want to focus, or if you have the time. And if you don't, then like I said, find a friend, and maybe they have some time. They'll print something out. They could potentially print something out for you, or find a service and you can pay to have something printed out for you. And likely it'll cost less than a kit. If you can find the kit online somewhere and send it to them, you can have them print 8 or 10, 12 of them for the cost of one kit. But you can have as many kits, many of that same kit as you want. That's the advantage to having access to a 3D printer, because once you have the electronic files, you can print as many of them as you want. Replacement parts, for instance. My 3D printer is built off of 3D printed parts. And if something were to break on it, for instance, you can see it here in this view, all these orange pieces, for instance, that's plastic. The blue piece over here, that's plastic. I can 3D print a replacement part for any of these parts. In fact, I have a few of them on hand in a box in case some of the key parts break. So let's see here. Let me go back there. That's the perfect one there. As you can see in this picture, there's lots of orange that you see in the picture. This is a big piece of metal here, but all these orange pieces are 3D printed parts for my 3D printer. And if necessary, I can 3D print replacement parts. And a lot of times the upgrades to this are just 3D printed parts. And I disassemble some stuff and put it together slightly differently, and it's upgraded. So all this orange that you see is a 3D printed part. Any more questions?
Okay, that was really great.
Awesome. Thank
Yep.
you all. Again, there's my email address right there on the screen. If you have questions, by all means, send me email. I'll answer your questions as best I
Jim,
can.
what kind of resin printer do you have, Jim?
It is, I'm drawing a blank for some reason. The Mono SE.
Is it Anycubic?
Yes, Anycubic.
Yeah. And I have the Elegoo Mars. And the reason I got this one is because it had great reviews, and I found it for right at $200 for the printer itself. It had great reviews, and they were about to come out with a brand new model. And so they were discounting the old model.
And that's what happened to me is they came out with a brand new model, and so I got the brand new one instead of the discounted one.
Yeah. I mean, they have a new one now that has slightly better features, but I can live with what I have for now. And probably in another year or two, I will replace my resin printer with an upgraded version.
And the one I have is basically the equivalent, just a different brand.
Mhm.
So you may or may not have noticed in all the excitement that we were extended beyond the 40 minutes. The message came up and said, congratulations. So that's very nice of them nice of Zoom to extend our meeting time. So we were able to get a full presentation from Michael. Is there anyone else that has any other questions or any other things that they've been working on at home that they just wanted to share before we end the meeting? Don't everyone speak at once.
I just want to say, Lil Dubs gave me a couple of things to work with. A 70 off-based gondola car and a Western Town kit. And I'm kind of working on those. I've found a way to kind of weather the trucks. I just got a can of spray paint, flat brown, and quick little put, just a quick squirt, and it looks like it's rusted, but not completely rusted. So I have a picture of that on my Facebook page.
Okay, cool.
So,
thanks. It's always fun to get a new technique down that you enjoy. Anyone else? I know Kevin's been posting some things on our Facebook page, and he's got some AP stuff we're going to be evaluating soon. I know that this was fun reviewing the 3D printing.
Mhm.
Like I said, I haven't had as much time as I'd like, but I'm pretty excited to be able to 3D print stuff, and I'm glad that I've got my printers. My next thing I want to get is a 3D scanner. I know one guy online that has scanned all of his friends that are in the train club, and then he takes that into the software, and I think it's like each figure it's spend about 30 to 40 hours refining them in the software after scanning them. But that's something I thought would be cool, is that we could scan. I know there's a service in Sandy that will 3D scan a person, but it might be one of my next purchases is to buy a scanner, not just for objects, but scanning us as a club. And that would be fun to have all of us on the layout.
Like Mount Rushmore.
Yeah. No,
So
just
Jim-
little people interacting.
So I have been getting signaling working on my layout, and I think you can see these. These are N scale.
Yeah.
So here's my finger so you can see the rough size. And this is from a company called Model Rail Control. I think Seth Newman is the person that runs these, but a dozen of these cost $12. And so basically these signals, they're not prototypical, obviously, but they function correctly. They can be properly driven. And if you're interested in getting into signaling, but you're not sure you want to spend $30 per signal or $50 per signal, these things are great. And I 3D printed some bases that would cover the areas that have to be soldered. You obviously have to solder the wires on there. And so I had to create a base that would encapsulate that, which I did on a 3D printer. But these, for $12, you get 12 signals. They're $1 a piece. They're 3 LEDs. As I said, the very low cost way to get into having some signaling on your layout if you're not sure you really want to. I primarily want animation, so I'm not about to spend $30 per signal at my stage, but thought you might be interested in this.
What printer do you have, Mike? What's
that?
What printer do you have?
I have the same as Michael does, which is the Prusa i3 MK3, and I also bought it as a kit, and I probably went through the same trajectory as he did, which is I had a cheap printer. It was an Ender 3, Creality Ender 3, about $200. You had to manually play with the bed, and everything is manual. It also has what's called a Bowden tube, and that is a white plastic tube that feeds the filament a little bit differently. And I also researched it for a long time. And the reason I bought the Prusa was because of incredible reviews, the ability to get documentation about it from the company before you went into it, and automatic bed leveling and direct extrusion without a Bowden tube, and automatic filament feeding, and the ability to change filaments automatically. You could do all those things with the Ender 3, but you can tell the print that I want to change colors at a certain point, and it'll start tooting or sending you alarms when it's time to change the color. So, you know, it's $750 if you build it yourself. It's $1,000 if you have it built. The Ender 3 was $200. I would say that it's sort of like golf or skiing or any other kind of thing where you're better off getting the $99 starter clubs until you decide if you're interested in it, and then spend the higher amounts, or the infinitely higher amounts that golfers spend on their golf clubs. Same with skis. Get cheap skis until you decide that you really care about it, and then get good skis. But I would say that the print success has gone up with the Prusa. I gave the Creality 3 to a neurologist, and the neurologist he's gotten magic out of that Ender 3 that I couldn't do. He takes medical scans of people's brains, and then he converts them into 3D print models, and he prints out a print of their brain so he can show them the abnormality that their child has on a 3D print. So he's been able to get much more out of it than I could. So, and I have trouble printing stuff. I just sent Michael a note that 3D, that little N scale fence on an identical printer, I must have something adjusted not right, because it always falls off it gets knocked off the bed. So it's a lot of tinkering, but same thought process. I think if you have more money, then more money gets you more creature features, like he said.
Yeah.
And he's demonstrating it's not that fragile.
Yeah, it's you can see it right there in front of my face. I got it twisted, but
Wow.
it's still in one piece. But it's, fencing. You just stick it on your model, and once you attach it to your model, it's fencing. You can't tell that it's flexible. You can't tell that you can twist it all the way around.
I'm going to look for that this afternoon and see if I can print that one.
Yeah. But once it's on your model, it's on your model, and it's good to go. Once you've got it painted and put it on the model, it is, and because it's flexible, if somebody accidentally touches it, you haven't just broken a piece of your model. It'll give a little bit. So
nice. Anyone else? All right, this has been fun and informative, which is a benefit. So, someone asked in the chat, where can we find the meetings? They're on our website. all the past ones. I've updated them so that we're all up to date as of this morning. I'll try to get this one loaded as soon as I can. And thanks to everyone for sharing and participating, and thank you, Michael, for that presentation.
Not
Like
a
I said,
problem.
if anyone else has any ideas and they want to share, get a hold of me or Charlie, and we'll get you in the lineup.
Yeah, and if I get a whole bunch of questions about one particular topic, then maybe I'll put together a presentation for that one particular topic. I mean, and then that could be a future presentation.
Yeah.
So, like I said, by all means, ask your questions. I will answer them as best I can. What I'll likely do is lump them all together in one message, and then have the question and my answer to it. And that way, because if one person has that question, it's entirely possible that somebody else has that same question, or they're thinking about it, they just didn't ask. So I'll try to, whatever questions I get, say in the next week or so, I'll try to aggregate them all together, answer them as best I can, and send it out to everybody who asked. Or actually, I'll get Rick to send them out to everybody in the
We
group.
can put them up on the website next to the recording.
Or that too. Yeah, that works.
Okay.
All right. Thanks a lot, everybody.
All right. Thank you.
You're welcome.
For everyone who wants to know about, if they do want to do a presentation like this on something else, just get a hold of me. I'll have my information. I'll give it to Jim and he can put it on the website. I think that might be a better idea than me
Yeah.
telling it.
Yep. Sounds good.